Hey, this is Aries from Stratoscale, and we're going to be going through a networking overview in Symphony. So I first want to go through a high-level overview of the different types of networks in the system, specifically what's required when you're actually going through and designing an implementation. So here I've actually mapped out a simple 4-node deployment, and you could see that there's 2 colored links from each server going to a set of switches. In this case, we just have 2. And this goes to a router or a firewall. I'll just call it a router. And that router uplinks to the cloud. And that represents obviously the internet, your ISP, other networks, whatever you'd like. Between these 4 nodes, each of these 2, each have 2 10 gig connections, Ethernet connections going down to the switch. And those would be in an LACP bond. And you can have more than 2. You could have 3. You could have 4. I have as many as you want, really. And you can see between those 2 switches, I tried to actually label the ports themselves in a vertical port failover way. So you can see if one of those switches were to fail, each of these nodes would still have at least 1 link up, so they could still communicate, which is important. Now, I want to look at the VLANs that we are basically tagging on these bonds. So between these 4 bonds in this example, we have to tag a range of VLANs. So first we need at least 3 VLANs just for the regional networks. And the regional networks are the API network, the data network, and the manager network. Now the API network is the only network that needs to be routable. And the API network is really what you'll be using to connect to your system. It's where the UI is located. It's where you SSH into the hosts. It's where you run your AWS commands against, or OpenStack commands against, where your RESTful endpoints are. And that is essentially a very important network, and that is why it's routable. The expectation is your users are all going to be on your layer 2 segment to access those nodes. So obviously this needs to be routable. The data network and the manager network don't need to be routable. They can simply stay within the switches as layer 2 networks. They will never need to talk to the internet. They'll never need to talk to any other networks. What's important is that all of the nodes are able to communicate on those 2 networks. Additionally, now we move into kind of like virtual networking, and this is networks that allow you to get connectivity to your VMs, your services, containers, etc. And we have 2 different types of networks. We have edge networks and we have private networks. Edge networks need to be routable. And from an edge network's perspective, it is actually like an uplink network for what are known as private networks. And private networks, just like their data and management, only need to be defined within a layer 2 fashion on your switch. They don't need to have any sort of route going outside of those switches, because we can use virtual routers within Symphony to route the traffic between a private network to an edge network. And we'll actually demonstrate that in this video. So you could see here that in all of these connections between the Symphony nodes and our switch, we have all of these VLANs kind of tagged. Our private networks specifically, in the case of us allowing tenants to go ahead and provision their own networks, we'll also need to define a range, because we don't want our tenants obviously being able to pick their own VLANs or segment IDs, and they can't, regardless. They can't do that anyways. But it's important to have a range to allow them to provision their own networks without having to wait for you to provision one for them as the cloud administrator. So these VLANs can also be defined as VXLAN. And we can get into that as well, or maybe we might spin that out into another video. But what's important to understand is private networks from a cloud model are supposed to be non-routable internal networks. Now, that's not to say that you can't have a private network that's externally routed. Say you really want to take advantage of some security features on your firewall, and you want virtual machines to be using their gateway rather than a virtual router within Symphony. You can go ahead and actually create a private network and point at the default gateway that you want. The important thing to understand is that as long as the traffic is defined, as long as the VLAN is tagged, going all the way back to the router, and that route is there, then that's important. That's the only thing that matters. And you have that control. If you don't want to provision things using kind of a cloud-centric model, you still want to take advantage of your old appliances, your old networking equipment, you can go ahead and do that. So we do support, I guess, both methods of deployment. So without further ado, we'll jump into the demonstration now. So immediately, I guess when we first log in, we see our regional overview. We're gonna basically go to the networks section, and we could kind of take a look and see that we already have an edge network defined. So as I was saying, this edge network is externally routed. This is a demo environment, one of many at Stratoscale, and our IT, our lab administrator, I guess, has gone ahead and created this for us to make it easier for us. But ultimately, you could create this yourself. The difference, there's no real difference in the menu when you're going through and creating a network, and I'll show you that in just a moment. But you could see this is the information. Like, this gateway exists on our labs firewall, and we are able to take advantage of the entire range of IPs. So Symphony is actually managing these IP allocations as well. So the DHCP services turn off on the firewall. We're allowing Symphony to hand out the IPs. The only thing the firewall is really providing is a gateway to route our traffic. And you can see here we have VLAN 153 defined. It's an edge network, and it's also shared. So that means any tenants that get created can also create routers and kind of reserve ports, and also provision floating IPs. And we'll get into all of this. Now, floating IPs, if you're not familiar with the concept of a floating IP, it's essentially you reserving an IP on that edge network for you to assign to a virtual machine to allow inbound connectivity. By default, if you assign a virtual machine to a private network that's being uplinked through an edge network, it only has outbound connectivity. Nobody can get back into it. So if you wanted to create, let's say, a website like an Apache server, or you wanted to be able to SSH into that VM, you wouldn't be able to without a floating IP, because again, that private network, the IP it'll have, that virtual machine, is not routable. The virtual router that we create is what's going to allow it to be routable. So we'll go ahead and do just that. Actually, we'll create a private network, and I'll call it private network 2 because I actually already have. I see one in the background here that I must have created earlier. Now I'm going to leave VLAN ID to auto select. As I was saying before, as a cloud administrator, since I'm logged in as cloud admin right now, you have a lot more control over this process. If I wanted to specify a specific VLAN here, I could. I could also select untagged if it was the default VLAN, or I was doing some sort of hybrid switch port model. But I'm just going to stick with auto select. We have a VLAN range which is valid here, so any VLAN I get should exist across all of the switches. All of the servers, all the nodes. So I should be fine. Now, disable embedded security here. If I were to check this off, it basically turns off the built-in security features of Symphony. So what is included, that we have anti-spoofing protection. So if your machine has an IP, which we know our DHCP server didn't hand out to it, it won't allow it to communicate with other VMs, or at all for that matter. We also skip the need for security groups completely. And for a lot of folks who kind of use this, it's during the transition to kind of adopting the cloud. This again allows you to treat this network more as a pure layer 2 network. You don't have to worry about anything. So you basically are taking care of everything from outside of Symphony. It's basically just a layer 2 network for your VMs to communicate over. Now, since I want to show off security groups, and I personally advocate for their use because it is another way to control and kind of secure your traffic, we'll go ahead and not leave this checked. So here you get to create your own subnet. Now, you have full control of this. This being a completely private network means you can pick anything you want. So I'm going to go ahead and pick 192.168. We'll go 9.0. give it a /24. Now, the gateway here is always going to be the first IP in the subnet that you define. So since I defined a /24, I'll have 253 IPs to choose from. I'm going to go ahead and pick the first one. And sorry, the first one is by default always going to be the router. And even though this gateway technically doesn't exist yet because I have to go create the router, we still have to define it because this is required for this network to even work properly, and this DHCP server is always going to hand out this information at the time of provisioning a virtual machine. So here you can actually define a specific allocation pool if you would like to. If you leave it blank, it'll assume you want to use all the IPs. So we'll actually do that. We'll just leave it blank because, again, it's a private network. We can do whatever we want with it. I'm going to leave it blank. So DNS servers, I'll just go ahead and pick Google's DNS. There we go. Private network 2. And you know what? I should actually maybe just clean this up. I think that I'm good to delete this network. Okay. So all that we should be left with now is Edge 1, private network 2. And this is another private network that someone else might have created, but since I don't want to bother, I don't want to mess with this network, so we'll stick with private network 2. We can look at its properties and see our allocation pool is actually consuming the entire subnet. And you can see we actually have 2 DHCP servers in this pool as well. And it actually will consume, again, the first 2 IPs of the allocation pool will actually go to the DHCP. So the first IP that will actually be assigned to a VM that gets provisioned in this network will be 192.168.9.4. And again, we'll show that off in just a moment as well. And here we have our DNS servers. Now, at this point, we can go ahead and provision a virtual machine into it. We basically just have a standalone private network. And if we go to our networking diagram, here we go. I mean, here it is. There's nothing connected to it. Here's our edge network. In fact, nothing's really connected to anything. Got some floating IPs over here. So let's go ahead and pop over to instances, and I'll actually deploy a CirrOS image. And if you're not familiar with CirrOS, it is a image used for basically testing and demonstrations. In this case, it's great because that's exactly what I want to do. I just want to kind of quickly spawn a VM, attach to it, and I'm expecting this virtual machine to not have any connectivity because it is attached to a network with no real uplink. There's no virtual router. It is going to have an IP, 192.168.9.4, as I said earlier. And if we connect to the console, it's still booting. We'll give this a moment. If we go back, we can monitor its information in here. You can see it's attached to private network 2, its IP, subnet information. And you can attach a virtual machine to multiple networks. I don't have to keep it on one. If we connect back to it, see if it's loaded up yet. There we go. We'll log in. Now, we have an IP address, but we can't ping anything. We definitely can't ping that DNS server. I think all we can ping on this network at this point in time is our DHCP servers. And actually, sorry, those don't respond to ping either, so we can't ping anything. Let's go ahead and get some connectivity to this VM. So if we go back home and we go back to our networks tab, we have our private network here with one VM attached to it. We see that it's actually gotten VLAN 169. And at this point, we need to kind of get these two networks talking. We got to get VMs on this network to uplink through Edge 1. And we do that with a virtual router. So we'll go ahead and create a virtual router. I'll call it vRouter 1. Edge network will be Edge 1, and our internal network will be private network 2. You can see actually I could actually select multiple internal networks. And this is important to know because you can allow these internal networks to also route between one another, which can be helpful, which can be useful if you're getting your services to talk and communicate between one another. So this router can also route between any additional networks you want. So if I want to pick net 1 as well, I could, or any others. So I just want private network 2, for example, and just to demonstrate the connectivity, I'll pick Cloud Admin default since that's what I'm logged in as, and we'll leave SourceNet checked off. There we go. Okay. At this point, you can actually monitor and take a look at some of the information about this network as well. You can see that these are the 2 networks assigned to it. We don't have any routes defined. By default, everything is open, everything is routable. There's no real stopping any traffic from flowing now. So by default, this is all you need to do. If we go back to our virtual machine, we should now have outbound connectivity. So we can go and ping, for example. We should be able to ping out. And if, I believe we should also be able to resolve domain names as well. There we go, I'm pinging google.ca. At this point, you might be pretty satisfied with that, but as you can see, I'm still, talking to I'm working with the VM through the console. At this point, I can't SSH in. The IP that it has is internal. It's a private IP range. I can't talk to this network. I'm in a position now where I want to talk to it. So the way I do that is with a floating IP. So we go back to our networking area and go to floating IPs. And you can see I already got some provision, but I'll just go ahead and provision another one just to kind of show off how easy it is. Floating IPs need to be provisioned specifically to an account and a project. Again, I'm logged in as Cloud Admin under default. So I'll just provision another one. And I will assign .8 to this VM. So we go back. Actually, before I go back, we can see there's actually a bit of activity now in our networking overview. You can see these are all connected now. Once I assign the floating IP is also actually going to be associated with our VM, CirrOS VM 1. And we can actually just jump right into the instance from this menu. So from here, we'll go ahead and attach our floating IP. And we're going to associate it with our internal network as well. So there's a one-to-one mapping as well. So just so it's clear to you as the administrator, the VM itself is not going to see that IP. Only you will know that as a Symphony administrator that IP is corresponding to that virtual machine. So if we go back to the VM now, we see that the UI is updated and .8 is now corresponding with this virtual machine. I believe at this point I should be able to ping this VM. If I go ping 10.17.153.8, I am getting responses. I can also SSH in, I believe. What is the username? It's CirrOS at, yes, 10.3.8. And there we go. I'm SSH'd in. Now that we're in, you can easily see how you can set up services such as a web server, any sort of service that requires outbound connectivity using floating IPs through the kind of cloud model that I've demonstrated here. And before I finish this off, I also want to just quickly touch on security groups. Now, because this is a lab environment, I believe our default security group has already had its rules modified. Yes, any. By default, egress traffic, by default, the default security group allows any traffic outbound. Inbound, it only allows connectivity actually between other virtual machines with the same default security group for that tenant, for that account. I always go in and I modify this in a lab environment to allow anything to get in because I'm trying to demonstrate things as easily as possible. But what I'm going to do is actually show how, even though I can ping it, I'm gonna create a security group that only allows SSH now. So I don't think pings will work anymore, but we'll go ahead and see. So we'll just go ahead and call it SSH, and we'll give it to cloud admin, and we'll define IPv4 ingress for TCP 2222 from any. So this is any source from the internet now can communicate in, and this is it. That's the only thing I'm going to allow. Actually, no, I'll also allow egress. Obviously, I need to allow egress traffic out. And there we go. IPv4. Okay. Now we'll go back to our virtual machine. And I'm going to detach the security group. And if you're wondering what happens now, by the way, I should lose connectivity. Yeah, and I did. Go ahead and ping that server again. And you can see it's not responding. I'll just leave this ping going, actually. Go back and refresh and see that there should be no security group attached. And we'll go ahead and attach SSH now. And you should still see our pings are still failing, which is to be expected. But I should now be able to SSH into this server. Oh, there we go. We get the prompt, and we're in. And we should still be able to ping outbound because our security group allows for it. Our UI still hasn't updated here. We go back to security groups. There we go. SSH. So, in this video, we kind of demonstrated quite a bit, actually. We went through the networking model, as it may be, in Symfony. We went through virtual machine networking, node networking, virtual routers, floating IPs, security groups, and how to go ahead and provision all of this and understand kind of how it works. Soup to nuts, as it may be. So with that, I'll finish off the video kind of looking at the networking overview screen, and you can kind of see the result of all of our work. Should you have a more busy cloud, you'll have multiple more objects in here, allowing you to get a good visual for all how the traffic is kind of flowing. Ultimately, everything will be terminating at your edge. Well, if you have any questions, feel free to give us feedback, and thank you for watching.